So children, on what factors G depends? Acceleration due to gravity depends on what factors? This is a question, children. Acceleration due to gravity depends on what factors? See children, this is the earth. Okay, as you go upward, okay children, as you go upward, means away from the earth, overall radius, if you see, overall radius increases, because till here is the radius. Still if you are going up, means it will increases. Yesterday we have seen that G is equal to Gm by R square. Okay, so G is inversely proportional to R square. So if you are going upward, as you go upward, okay, so acceleration due to gravity decreases with the height. Okay, children, with height, what happens to the acceleration due to gravity, children? With height, acceleration due to gravity decreases. As you go up, as you go up, acceleration due to gravity decreases. Okay. Okay, please see here, children. Earth is not a perfect sphere. Somewhat it is present like this, children. If you see here, children, all of you, this equatorial radius is a little bit more. Children, at equator, radius is more. At poles, equator is at poles, radius is less. Try to understand. Earth is not a perfect sphere, children. It is bulged at the. It is just flattened at the poles. So equatorial radius is more. Polar radius is less. Now, we know G is inversely proportional to R square. Acceleration due to gravity is inversely proportional to R square. Yesterday we discussed this formula. I hope you all remember. Children, because at equator radius is increasing, G decreases. Because at equator radius is increasing, if you go at the equator, acceleration due to gravity will be less. And at the poles, as at poles polar radius is less, acceleration due to gravity increases. So children, first I told about the height, then I told about the equator, then I told about the poles. With height, acceleration due to gravity increases. With equator, as you go to the equator, acceleration due to gravity decreases, and at the poles, acceleration due to gravity increases. Next, with the depth, if you go into the earth, if you go into the earth, what happens? Children, if you go into the earth, we all think that G is inversely proportional to R square. So as you go down, radius is decreasing, so acceleration due to gravity increases, sir, you will think. But children, as you are going into the earth, the density of the earth should be considered. As you are going into the earth, the density of the earth should be considered. As you are going inside the earth, the density of the earth also should be considered. G is equal to, please see here, Gm by R square. G is equal to G by R square. Mass is equal to density into volume. Mass is equal to density into volume. Density and volume of sphere. Can anyone say what is the volume of sphere formula? 4 by 3.
4 by 3 pi r cube.
Pi r cube. This and this has gone. So G is directly proportional to radius. So in the case of the body is going down, as radius is decreasing, G also decreases. Okay, children, as you go into the earth, as radius is decreasing, G also decreases. Okay, children, only in this case you have to consider the density of the earth. Why, sir? Means because we are going into the earth, that's why density of the earth should be considered. And if ever any mineral deposits are there in a particular place, then G decreases. With any minerals deposit, G decreases. Okay. G decreases with the mineral deposits. Okay, children. Overall view differences between big G and small g we will discuss here. Overall differences between big G and small g. Okay. So children, big G is called as universal gravitational constant. Small g is called as acceleration due to gravity. Small g is called acceleration due to gravity. Big G units what, children? Newton meter square per kg square. Small g units what, children? Meters per second square. Big G value how much, children? 6.67 into 10 to the power of minus 11. Small g value how much, children? 9.8 meter per second square on the earth. Big G never changes from place to place. It is constant all over the universe, not on the world. It is constant all over the universe, children. But G changes from place to place. On the earth only it is changing so many times. On other planets, G is completely changes, children. So these are the differences between. And if you want formula for G, What is the formula for G, children? Yesterday I gave FR square by
FR square is
M1
equal
M2.
to M1 M2.
And what is the formula for small g, children? Small g is equal to F by M. Small g is equal to F by M. This is how we have to, these are the differences, children. So if ever I ask the differences between big G and small g, 1, 2, 3, 4, 5, all those 5 differences you have to write in an exam on Sunday. If ever, and if I ask factors, you have to write all these factors: height, equator, pole, depth, minerals. Height, okay, what are the factors? Height, equator, pole, depth, minerals. You have to write all these factors, children, how they are affecting, whether they are affecting directly or indirectly, everything you should write, children. Okay, children. So this is about the differences and this is about the factors, children. We'll do 2, 3 numericals, then you will have a clear understanding, children. Just for practicing, I'm giving, children, just for practicing. Okay, don't take it seriously because G value does not change from place to place. Okay. First question: find G on Earth if 100 Newton weight has mass of 10 kg. Has mass of 10 kg. Children, G is equal to, what is the formula? F by M. What is the force I gave? 100 Newton. I mean to say weight. Weight means 100 Newton. What is the mass I gave? 10 kg. So 100 by 10, approximately 10 meters per second square. Approximately 10 meters per second square. Find G on a planet whose weight is 200 Newton and mass is 10 kg. Find the G on that planet. There is some planet, we don't know. Where 200 Newton body weight is 10 kg. 200 Newton body weight is 10 kg. What is the formula for G, children? F by M. 200 by 10. So answer 20 meter per second square. 20 meter per second square. Third question, children. Find G on a planet whose weight, okay, whose weight is 300 Newton and if mass is 10 kg. What is the acceleration due to gravity on that planet? G is equal to F by M, children. So F weight, how much I give, children? 300 Newton and mass is how much, children? 10. So 30 meter per second square is acceleration due to gravity in that planet, children. In that planet. One more question. Find capital G, children. On capital G, don't actually, children, compulsory value is 6.67 10 power minus 7 all over the universe. Any changes are occurring in this sums, don't worry, children, just for practice I'm giving, children, that's all. Okay, if F is equal to 100 Newton, R is equal to 10 meters, M1 is equal to 2 kg, M2 is equal to 5 kg. M2 is equal to 5 kg. Find the value of big G, children. Find the value of big G. Tanmay, can you tell Nana?
Yes, sir.
Hmm.
G equals to F into R square by N1 N2.
Okay.
G equals to 100 by 2 into, sorry, 10 into 10 by 2 into 5.
Okay.
100 in,
1000 Newton
sorry,
meter square per
1000 by K.
kg square. 1000 Newton meter square per kg square. Okay, children. Next question. Find G of a ball. Find big G, children. If force is 500 Newton, radius is 1 meter, M1 is 2 kg, and M2 is 5 kg. Okay. Larry, can you tell?
Yes, G is equal to F FR square by M1 into M2.
F is equal to, yeah, G is equal to FR square by
M1 into M2.
M1 into M2. G is equal to
500 into 1 square
500 into,
1 square by 1 into 1 by 2 into 5.
okay, this gone. So G is equal to 50 Newton meter square per kg square. Okay, children, like this. One more question, children. Find G if F is 1000 Newton, R is 2 meters, M1 is 2 kg, M2 is 10 kg. Okay, Sneha, can you tell what is the formula for G?
So G is equals to FR square by M1 into M2, 100,000 into 2 by 1000 into 2 into 2 by 2 into 10.
2 into 10. This 2 gone. 10, 10 gone. So answer
200.
Newton
200 Newton meter plus.
Q square. Okay, children, like this you have to do, children. Okay, so many numericals I have told children. Actually, numericals won't come from this, children. The weight and like weight and mass and acceleration due to gravity they will give. But that I have told in recent classes difference between weight and mass. I told you, no, children. In that I told numericals. Basing on this numericals, you have to study only the 5 differences, whatever I told, and these factors. With height, what happens? With equator, what happens? With pole, what happens? With depth, what happens? And in my video, in the description, I will give all these notes, children. Please go through that notes, and also some numericals examples I will give. Please do that numericals also. I hope everyone copied this, children. Children, did you copy everyone this one?